Hi friends, in this session I am explaining the extendable hashing in a simpler way to solve the numerical. Let us take a numerical to solve the extendable hashing, and we have this numerical on the slide where we have to insert these numbers 32, 28, 43, 15, 66, 27 to the directory, and we have given a hash function by which we calculate the hash, and given that there is the BFR of 2. BFR is the block vector for the records which we contain. If we have given a block of 1000, and given that sometimes we have to calculate the BFR, so I am explaining that what is the BFR and how to calculate it. So sometimes given that block size is 1000 and the record size is 300 KB, so we have to calculate the BFR. So BFR equal to 1000 divided by 300, and we get the something 3.33. so we take the floor value, okay, only 3. Okay, and after taking the floor value, we have given BFR here in this question, but sometimes we have to calculate. Now to solve the problem, we have calculate the hash. So we perform the hash function here on 32. So we get the 32 mod 10 equal to 2, and 28 mod 10 equal to 8, and so on. So by applying the mod 10 function, we get the 2, 8, 3, 5, 6, and so on by numericals. The numbers given you can calculate, and now we convert the binaries of these, like 2 we can convert 0, 2 के लिए 1, 0, 0, and now you know how to convert the binary. So for at 1 triple 0, for 3 0 1 1, and so on. We calculated the binary. Now we have also given that you have to start with the global depth and local depth. What is the global depth and local depth? You have to understand to solve the numerical. The global depth is the number of addresses a table can contain. It's a hash table who points to the buckets. Okay, it's the hash table is depend on the global depth, and the buckets increased or decreased by the local depth. Okay, the main thing is the hash table size. It can be increased or decreased as per requirement. Okay, so this is the extendable hashing, and we have to set the global depth of 2 to, so the number of rows in a hash table is 2 to the power 2. Okay, 2 to the power which is this given. If the global depth is 1, it's 2, so we have the only 2. Okay, now it's in 2 to the power 2, so it's 4, and it may be increasing as we process. We see how it's increased and how local depth is increased. Now for further processing, I make a table for the numbers and their binary hash. Okay, okay, so here is the number and its binary hash. Okay, we start with global depth 2 as given in numerical, and local depth 1. So as I said, there are the in hash table we have the 2 to the power 2 rows, which is 4 rows. So we given the number 0, 0, 1, 1, 0, 1, 1. Okay, it's the binary. Okay, for it's in binary, we have take the 2 to the power 2. Okay, now it points to the some buckets. Okay, local depth is 1, so we create the 1 bucket for each MSB. Here is the MSB is 0, here 1, here 0, here 1. Okay, these are the MSB. For these MSBs, we draw 1 bucket, and 0 will point this, and this 0 will point this, and this one will point this one will point this. Okay, since BFR equal to 2, so we have here 2 records can be contained. If BFR is 3, we can draw 1 more, and so on. Okay, now we start with insertion. Now when we start and global depth is 2, we see the 2 bits. Okay, here is the 1 0, so 1 0, which bucket is point 0th bucket, so we insert the 32 here. Now more process, again 0 0, so 0 0 we find here, 28 inserted here. Okay, and 1 1. Now 1 1. So 1 1 when comes to 1 1, 1 1 43. So 43 here inserts here. 0 1, 0 1 comes to here. Okay, 0 1. So 15 goes here. Now insert 66. So 1 0. Now when inserting 66, we have all the buckets are full. Okay, so what we do, we see the MSB. So 1 0, 1 0 complete is this. Okay, 1 0, when we see 1 0, its buckets are already filled, 32 and 28. Okay, so we given 0 0 their separate bucket and 1 0 their separate bucket by increasing local depth of 0 0 to 2 and 1 0 to local depth 2. Okay, we only give their separate bucket, nothing more else. Okay, and with one is no conflicting in there, so they are pointing to same bucket, no problem with it. Okay, and when 0 and 0 1 0 get their values, so we have to reinsert the all elements except whose MSBs are 1. So is its MSB 0? Yeah, its MSB is 0. So 32 where goes to 1 0. So 1 0 where the 32 goes there. Here is 0 0, MSB is 0, so we have to check whether where it go to 28. So 28 got to 0 0, and when we comes to 43, it's 1 and it's 1, MSB is 1, it's again 1 0. So 66 goes to 1 0. Okay, now inserting 27, double 1. Oh, double one pointing to this bucket, and this is already full. There are the two elements already. So what will we do? We give buckets to their separate. 0 1 has a bucket and double one has their one bucket. So when inserting 27, the 00 and 10 are not affecting, but the 0 1 and 1 1 get their own bucket. Okay, so when 0 1 and 1 1 get their own bucket, so we have don't check to the 0 MSB, but 1 and there is the 1 MSB who's in number. We have to check and reinsert them. Okay, now if we check the 32, its MSB is 0 28, so it's inserted already as they are, but it's here is the double one. So 43 gets inserted in double one bucket. 0 1 15 whose 0 1 is there, so it's inserted in 0 1 bucket. Okay, and when talking about 66, it's in 1 0 bucket. So 66 its MSB is 0, so not worry about it. 27 is inserted here, double one bucket. Okay, clear now? I think it's clear now, but as we proceed, we see the how increase the global depth also. Here we increasing the global depth. Now we have here if this bucket have global depth of 2, this bucket have 2, this bucket have 1, because they are the pointing to 1. But here is the all have their own bucket, so global depth is all of 2. And there is the one principle that always lower depth is local depth is always less than global depth or equal to global depth. Okay, so following this principle, we always follow this principle. Okay, now inserting what? After 27 we are inserting 1 0. When come to the 1 0 1 0, oh, it's already full. So what to do? Now we cannot increase the local depth. If we are increasing, it's violation of this rule. So we increase now global depth. Okay, so if we increase the global depth, there is the 2 to the power 3. Okay, because the global depth when becomes 3, so the number of buckets are 2 to the power 3, means 8 buckets are there. Okay, so we are moving to the numerical next, and I think here is the not at table. Okay, I will see that there is the when for increasing the bucket, we only repeat 0 0 2 times, 0 1 2 times, 1 0 2 times, and double 1 2 times. Okay, and write one time 0 0 in front of 0 0 and one time double 0 1. Okay, one time 0, one time 1, one time 0, one time 1, one time 0, and one time 1. it's are 8 buckets. Okay, you can check whether it's are 8 buckets or not, or none of them are repeating, I think so. Okay, and now we are checking now two MSB beats. Okay, 00 and 00. Okay, 01 01 10 10 means we are checking of two bits. Now 00 pointing to the 00, they are not conflicting, only we separate them who are conflicting. Here what are conflicting here? Here is conflicting the pair of 10. So we divide the 10 to 0 0 10 and 110 and give their separate buckets. Okay, and 1 not conflicting till now, so we insert it here, and now we reinsert here. Actually I want a table, so I keep insert here. Okay, 1 second. We have to I insert this table here. Okay, wait. Oh, okay. Oh, this table is here. Okay, now we reinsert here. So we have to see now 3 bits. Okay, so we have to see now 3 bits, 0 1 0, where it goes 0 1 0. So 32 goes here. Oh, great. 0 0 28 belongs to here, and 0 11. So 0 11 where it 43 goes here. 101, so 15 goes here, and 110, so 110 what 66 goes here. 111, so 27 goes here, and 10, which is conflicting in last insertion, so 86 110, so go here, and we have now inserted elements of now 111 57, so 57, now 57 conflicting here, because where yet all the 111 bucket is already full, so we give that 0 11 their bucket and 111 their bucket. Okay, so we give this and give their separate buckets as shown here, and then we can reinsert here. Okay, all the elements. Okay, 28 32 0 10 goes here. Okay, 000 28 goes here. Okay, sorry, 0 10 0 11, where is the 0 11? So 43 goes here. 101 for the 15, 101 for the 15, and 110 for 66, and 27 111 27 goes here. 86 110 already here, and now 56 57 which conflicting here, so 57 111 is now empty, so we can insert the 111. Now again 101, so 101 where the 101, here is the empty space as you see here, so we insert here. Okay, and 000 98, already here is the blank space, so we insert the 98 here, and 010. Okay, so 010 pointing to 32 bucket and 72 inserted here, and this is the complete structure of directory. Okay, I think you have understand it, and it may be beneficial for you, and thanks for listening and watching this video. Okay, thank you.